Hello, Assalamu alaikum. My name is Salman Soha. My metric number is B0319104880. I am from BITS. In this video, I am presenting algorithm analysis assignment 2. This is based on divide and conquer algorithm. So this is our group member list. We have 4 group member. Now I am gonna start with introduction. So for this assignment we choose merge sort algorithm. So what is merge sort algorithm? One of the most common sorting algorithm based on the divide and conquer algorithm principle is merge sort. We need to determine what our subproblem would look like. So we use divide and conquer to sort. The whole thing is working out an intercollection. Merge sort constantly break down a list into several sub-unit. A single element is comprised of each sublist, and such sublists are combined in a way that result in a sorted list. The unsorted array of n element given in merge sort is divided into n subarrays, each with one element, since a single element is always sorted by itself. Then to construct new sorted subarrays, it repeatedly merges these subarrays, and finally one full sorted array is created. So this is the merge sort mechanism, how merge sort manage the sorting system. So now we can see a example. So the example is, if the original array has 6 elements, we slipped the given array halfway in the merge sort. Then the merge sort would break it into 2 subarrays of 3 elements each. Then we are going to split these subarrays into still smaller subarrays. Before we have several single element subarrays in them. Now the assumption here is that an array with a single element is already sorted. So we have successfully broken down our dilemma into base issue until we split the original array into subarrays that have only a single element, and then step by step we have to combine all of these sorted subarrays from a single sorted list. Okay, so now we're gonna show a example on real life. So just like when British came to India, they saw a country with different religions living in harmony, hardworking but naive citizen. One unit is diversity, and found it difficulty to establish their empire. So they adopt the policy of divide and rule, where the population of India was collectively one big problem for them. They divide the problem into smaller problems by instigating rivalries between local king, making them stand against each other, and this worked very well for them. So well, that was a story. This is a story, but the idea here is, if we can somehow divide a problem into smaller subarrays, it becomes easier to eventually solve the whole problem. So this is the basic thing of merge sort. Thank you so much. Next part will explain my other teammates.
Assalamu alaikum, this is Abdul Hadim Espa. I'm going to explain merge sort in here. So for merge sort, as we can see, we have an array of 8 elements. So the very first thing we need to do to execute the merge sort, first we need to divide this array into half. Like we have 8 elements in this array. So what is half of 8? 4. So we made 2 arrays containing value 4 elements each. The next step is similar like this one. The very first time we had 1 array, now we have 2, and we need to divide this 2 into 4. Like this array here is going to divide in half with this and this. As we can see, this array and this array came from here, and these 2 from here. It's simple. The next step is also divide. We need to divide these 4 arrays into 8 arrays. So each array has now one element. Let's go to next page. Here what we are doing, we are comparing possible two array and sorting which one is greater than which one. As we can see the previous one, here we have the first one is 55 and the second one is 20. This next step is sorting with these two array, these two array, these two array, and these two array. And here we can see that here 55 was the first one, 20 was the second one, and after sort 20 is the first one, 55 is second one. Here is the same. It's not changed, but the third one is changed. 48, 24. We're seeing here 24 and 48. The next step is actually distinguish, or we can say match with these two and these two, and check which one is smaller. The smaller one gets the first place, the bigger one gets the last place. So as you can see in this two array, the 11 is the lowest, this is going to be first, 20 is the second lowest, going to be second, 36 the third lowest, going to the third position, and the 55 will be the last element. It's same for this array as well. Now the last step, we need to merge these two finally in one and compare all the data in sorting system. Like the very lowest one will be the first element, and the very highest one will be the last element, as you can see here, 11 and 78. So basically it's merging sort is like, first we need to take an array, then we have to split it in half, then again half, then again half. After that, while we are remerging the arrays we already split up, in this process while we are remerging, we need to execute the sorting system in that process. So as we can see, first we are dividing everything, and while we are merging, we are performing our sorting here, and finally we have the result. So that's it for me. Thank you so much. Our next friend will take the next part. Assalamu alaikum.
Assalamu alaikum. I am Mirza Shahid Afridi, and today I am going to explain the merge sort algorithm. And on the left hand side I have written the merge sort algorithm. On the right hand side there is a tree format where I am going to implement the code. So first I have taken an array of size 5, and this array will call the merge sort, first merge sort. So when the merge sort is called, it will check the left index is less than the right index. So in this case the left index is 0 and the right index is 4, so 0 less than 4 is true. Then it will go to calculate the midpoint. So the midpoint is left index plus right index divided by 2. So 0 plus 4 is 4, divided by 2 is 2. The midpoint will be 2. So after that it will call a new merge sort, and because it is a recursive call, so the first merge sort step will pause, and this array will divide it into two parts. So here is the two parts which have divided. Then this first part will call the merge sort, and it will again check the if statement is true or not. So in this case the 0 less than 2, it's true. Then it will calculate the new midpoint, which is 1, and again it will call the merge sort, and this merge sort will pause and this will divide into two parts. So this function will again call the merge sort, and the left index is 0 and the right index is 1, and the if statement is true. So the midpoint will be 0 because 0 plus 1 is 1 divided by 2 is 0.5. So it will not calculate the point functions, it will not calculate the points, so it will be 0. So it will divide into two parts. When this step comes, it will call again the merge sort, and it will check the left index is less than the right index, but in this case it will be 0, so this will not be true and it will go back here, and this step will resume. So it will go to the merging bar. So here I is equal to left index, so and the j is mid plus k, which is 1, and so mid plus k is 0 plus 1 is 1. So this will be, and the k is the temporary array. So here it will check the while statement if I is less than equal to mid and j is less than equal to right. So here the I is 0 and it is less than equal to mid, so mid is 0, so it is true. And then the j is 1 is less than equal to 1, so it is true. So here it is true, then it will come to the if statement. It will check the if j is less than equal to array I is less than equal to array j, so it will check and compare. So when if this statement is false because the j is 5 less than 4 is not true, so this will not execute and it will go to here. So I is true, so it will go here and the 5 will go here. So this step will continue until the whole array is sorted in order. Thank you.
Hello, Assalamu alaikum. Once again, my name is Sadman Zoha and my matric number is B0319104880. Now I am gonna talk about complexity of merge sort, the time complexity and the space complexity of merge sort. So merge sort is quite fast and is also a stable sorting algorithm. That implies that in the sorted list, the equal elements are arranged in the same order. A running time of order n will be required by combining the sub-array generated by dividing the original array of n elements. The cumulative time for the merge sort function then become n into log n plus 1. So that provide us with a time complexity of order of n into log n. So the time and space complexity for merge sort algorithm is: worst case time complexity is big O n into log n, best case time complexity is big omega n into log n, average case time complexity is big theta n into log n. Space complexity is order of n. In all three instances, worst, average and best, the time complexity of the merge kind is order of n into log n, as the merge from often split the array into two halves and takes linear time to merge two halves. So this is about the time and space complexity about merge sort. Thank you so much.
Assalamu alaikum. My name is Nafis Ahmed. My metric number is B0319104881. So I am gonna compare with an algorithm which is better than merge sort. We think quick sort is better than merge sort algorithm. Merge sort and quick sort algorithm both are divided and conquer technique. Merge sort works by separating a given array into two equal size sub-arrays. Individually sort the sub-arrays using recursion. Merge the sorted sub-array and get the response to the original array. And quick sort, it functions by locating an element in a given array called a pivot. Array the partitions into three sub-arrays and recursively arrange the arrays. Merge sort uses extra space, needs little space for quick sort and shows good change place. Due to less data movement, quick sort is faster than merge sort. In practice, quick sort is usually considerably faster than any other algorithm since its inner loop can be easily applied on most architectures, and it is possible to make and design choices in most real-world data that reduce the possibility of needing quadratic time. The quick sort is an internal sorting system where the data in the main memory is sorted in comparison. The merge style is an alternative sorting system in which the data to be sorted can not be processed in the memory and the auxiliary memory used for sorting can be sorted. So because of these reasons, we suggest that quick sort algorithm is better than merge sort algorithm. Thank you.